Okay, good evening, everybody. We're going to get started with today's lecture on authentication. So before we get into class, a couple of quick announcements. So PA6 on deployment is due this Wednesday, same time, same place, CMS. But the great part of this is that there are no more assignments for the rest of the semester. Yay. So congrats on coming this far. After this, it's just the hack challenge. And the hack challenge essentially a 2-week hackathon with students from other apps of courses. So essentially front end will either be intro to iOS or intro to iOS, intro to Android, and backend is this class. So it is required for everyone. It serves as your final exam, final project for the class. You are able to win awards and prizes, best UI, best user interface, most creative, and also particularly for this class, best backend. And for freshmen and sophomores, junior, well, to be fair, for everybody, it's a great way to add another personal project for your resume, because essentially you are building an app from scratch. It's your own idea, your own creation, and essentially you will be the back-end developer for a fully fledged app. And you'll be working on a cross-functional team, so you'll gain experiences working with other people in different roles, because maybe thus far in CS you've only worked with other developers doing something similar to you, but this will be a great way to gain experience in working with a developer having a completely different role, considering half will be front end, half will be back end. And also you may or may not have a designer from the intro to digital project design collaborating on your app with you as well. The kickoff is, these slides need to be updated, but the kickoff is next Monday, 11/9. What's next Monday?
Sorry, I forgot to update that.
Yeah, whatever next Monday is, it's next Monday. So a week from today, which is why move past this Wednesday, you have no more assignments. It's solely focusing on the hack challenge. Team matching form will be due this Friday. Yeah. So again, sorry about the messed updates, but kickoff is next Monday. Team matching is this Friday, and team matching mixer TBD. So basically the team matching mixer is basically a way to find other people to collaborate with, whether that be front end or another backend member. Traditionally, teams usually consist of 2 front end, 2 back end, maybe 1 design, depending on numbers. Contact us for any questions, and we'll be making an ed post with a lot more details and the correct dates. Okay, so with all that said, does anybody have any questions? I feel like I just gave a lot of information about the hack challenge. Does anybody have any questions regarding it? Okay, cool. So moving on to review. So we've talked about HTTP communication hypertext transfer protocol, which is essentially moving information from the front end to the back end. We have information being sent between the client, which is essentially your phone, your computer, whichever user's device is requesting requesting the data from the back end, and then the server, which is essentially just another mega computer that handles all of that data. And this request, basically the request asking for that data basically contains the URL, which is essentially where exactly is. Think about the address of where you want to go. That could be that's set up using DNS, domain name server protocol, that we talked about earlier. The query parameters, which is essentially specific what kind of data, and then the method and the dot body, which is the specifics body is this, done is that, that we talked about earlier. And then you have that request that goes from the client to the server, and then you're going to have your response going back from the server to the client, which is going to contain the information that you requested and your status code, which is 200 if it worked, 400 if it didn't, your success, failure status codes. Okay, so given all that said, given your requests and your responses, you want to essentially incorporate users in the sense say you're on your YouTube app, how do you know which user's feed you want to pop up? Because if you're logged into YouTube, you want a feed tailored to you. If you're on Instagram, you want the Instagram tailored to you. Also, you want to deal with permissions for recess access and manipulation. So meaning say you're on Snapchat, you don't want everyone to have like access to your your personal snaps. If you're on Instagram, you don't want everyone having access to your DMs, right? So basically, every application needs a way to identify the users making the requests. Basically, how do you know that this user is the actual user that is supposed to have access to this information, these resources, essentially? And basically, how do we verify who is sending these requests? Like, how do we know it's really you? And the answer that, well, a way to do that could have been like, oh, every user, you just like, every request you just send in the username. So in this example, we're on Rahi's account, you just send in the username Rahi, but then how do you really know that this is really Rahi? How do we know that Rahi is the user sending this request? Because honestly, anybody could really just like somehow edit this query and then put in any username you really want if you have this method. So the solution to this is using something called authentication. And it includes additional information to verify that the user is in fact the user that they claim to be. And authentication allows you to validate server requests based off provided credentials. So like think about like building off the idea of like having a username and password. So authentication basically allows you to validate that the user is in fact that user. And authentication allows you to create specific permissions based off of user identity, which essentially is again allowing certain users certain access to given resources if they're actually authenticated. So thinking about okay, you're signing up for an app. You first need to like register and log in. So you're going to first enter your email and your password and you're signing up. So again, building off the idea of having a username and password. Oh, yeah. So in this example, you have the credentials sent to the database. It's encrypted and stored. And for those who don't know, encryption is basically you're given a piece of data and it's essentially scrambled to basically hide and translate it into something else. So it's just encryption is basically just a way of making the given information be coded and then it eventually has to be decoded. So in this example, you have like your username and password. These credentials are sent to the database. And then it's authenticated if the pair actually exists. Like say if that username and that password exists in the database, then it's actually authenticated. Oh, why is it? Oh, yeah. And then building off this idea, HTTP requests contain request headers. So to be fair, you could like store the username and the password in the body of the requests, but typically you want to save the body for the actual information related to that specific request. So we use the request header instead, and that contains metadata about the request. So essentially, you can think of metadata as data about that data. So think of it as kind of like a smaller, like a separate level of data. It's basically metadata is like data about data. And the HTTP request headers, it can contain the content type. So the request body information type, like, so for example, in this class, we've been dealing with JSONs. So in a given example, the content type will be JSON. And then it can contain the cookie, which is the user state information. We'll talk more about cookies a little bit later. And then it contains the user's agent, which essentially is like, okay, this is the Windows computer and you're using Chrome, like a Chrome tab. And then lastly, it contains authorization, which basically allows you to, authorization is basically like the credentials to allow a specific user to access certain information. So here we have an example of a request header. You can see like we have like the method, post, the path is URL, like a bunch of information. We have like the cookie, more on that later. And we'll talk more about cookies later. Okay. So there are 3 types of authentication schemes: HTTP basic, HTTP session, which is like linked to cookies, and then HTTP token, which is essentially like the best out of the 3. So first, starting off with HTTP basic, you're making a new account, you encode your user and password, and then this information is cached on the front end of the device, and then you send the encoded credentials with every request to the server. And then the server validates the encoding credentials, which basically means that you send your, you send your username and this is not working. Okay, so you register, you send your username and password, you create the new user, and then you return your success response. And then just going back a little bit, here's an example. So this is basically an encoded version of your username and password. And then it has basic in front of it to show that the type of this is basic. And then, so you could have like the username and password, like JZS27, and then password, like password being my password. And then those two units of information are then encoded to make my username and password. And notice how like this looks very different than like JZS27 password. Encoding is just basically like changing it up in a certain way to then make it be decoded later on. Okay, so this is what we went through earlier. You send over the username and password, you create a new user, then you return the response. And then later on, success, you make a new user. And then later on, if you want to log in again, you then send from the client to the server the encoded credentials. You decode the credentials, you validate the password, essentially like, is there a match, yes or no? And then you return a response, whether that be a success, and if like, say the password doesn't match, that's gonna be a failure. And so the advantages of HTTP basic, well, it's basic. It's very simple. It can be used by essentially any front end. Like you don't have to like change your backend to a certain way to be compatible with your front end or vice versa. It's just very, very simple, very, very easy to use. So essentially like it's very accessible and anybody can use it essentially. But can anybody tell me like, what is a disadvantage of this possibility? Like you're sending all this information, like this technically like confidential, sensitive information from the front into the back end. Can anybody tell me or think of a possible disadvantage of doing this? Okay, well, oh yes, Justin. Cross-platform? Possibly. Well, okay, that wasn't the example I was gonna give, but yeah, well, yeah, the drawbacks of this, like the cons, would be like essentially your username and password would be exposed in each request. Even though your username and password is decoded, basically every time you make a request from the client to the server, it's being exposed. So say you're like, like when you go to like a public coffee shop and they say like, oh, is this a public server or is this a public network? And you select yes or no. The reason for that is like, say you're on a public server, you're sitting in your local coffee shop. So for some way, somehow someone finds a way to essentially find out your username and password. You might be in trouble because like people tend to use the same password across different accounts. So basically you're potentially exposing your username and password multiple times since you're sending it from the front end to the back end on each request. And again, the username and password is stored on the front end. So essentially, again, you're storing potentially sensitive information on the front end. And this level of security depends on HTTPS, which is like hypertext transfer protocol secure, which essentially you're basically like giving up the security of your app to this one piece of technology, essentially. So moving on to the next type, we have HTTP session, which deals with cookies. So again, you send your username and password to the server validates these credentials, and then the server generates a session with a associated cookie. And then you cache the cookie on the front end, and then the cookie is sent on every request to identify that user. So essentially the main difference between this and HTTP session and HTTP basic is that instead of sending your username and password with every request, you are instead sending the cookie on every request. So here's an example of a cookie. It's basically just like a random string of some form. And here we can see the correlating session. And then the session identifier. Oh, yeah. So we have the session and the session ID right there. So here's just another walkthrough. We have a registration. You're making a new user and password. You create the new user, you create the new session, and then instead you return that cookie. You have the cookie is going back from the server to the client. And then in the future, when you're trying to authorize the user, instead of sending your username and password, you then send your new cookie. Then you parse the session code, you validate the session, aka checking, does this cookie match? Is this a valid cookie? Yes or no? And then you return the response. And then in cases where the session expires, you return the response that, hey, this cookie's expired, you need a new one. And in that case, you simply just log in again. So in this case, notice how instead of sending your username and password every request, you're just only sending your username and password when you need to re-log in when your session has expired and you need a new cookie. Oh, so then you re-log in, again, you validate the credentials, you make the new session, and then you return your new cookie. So the benefits of this is, again, as I mentioned earlier, you do not have to be sending your username and password as often, so it's not as exposed as it would be in HTTP basic. And you can tune expiration time between user convenience and security. So like, you know how when you're logged in on Canvas, you have to like log in, provide your username and password the first time, but then say you close the tab and then you go back like 5 minutes later, you're still logged in, you don't have to log in again. So basically you're able to like tune how often you have to log in based off of like the type of application you have. So for example, it's like if you're logging into your bank app, you'd want to like require a new cookie every time. But if you're logging into Canvas, you'd like require a new login, like I guess like every hour, every 2 hours, depending on like the needs of your users. And then basically the drawbacks of HTTP sessions is that it saves session data in memory. So that just essentially, it takes up space. And if you delete cookies from your browser, you then have to authenticate, which essentially, you know, like some websites say like, oh, do you want to like save cookies or delete cookies? Essentially, basically like you have to re-log in if you do that. And then lastly, moving on to our final type of authentication schemas, we have HTTP token, which is very similar to HTTP session. So we have send username and password to the server as per usual. The server validates that. Then the server generates and returns a unique access token. Then you cache the access token on the front end. Access token sent on every request to identify a validated user. So essentially, like instead of returning a cookie, you return an access token, and then we'll get into the difference between the two in the demonstration. So here's an example of an access token. We're logging into, okay, I'm guessing this is Google. We're getting some files, and this is the type. This is for the token. It's just called a bearer, and then this is just like the token, it's a random string. So in this case, we have like our users, we have Kate and Shungo, and then we have another like token table. So we have like the ID for the token, and then we have the ID of the user associated with that token. And then we have the access token. Is everybody following? Okay. And then token expiration. So basically you can design access tokens to expire after a period of time. So that's very similar to like the cookie where you can like design how often do you essentially like, actually I don't say that. Okay. Yeah. So token expiration, you can design how often or how long you want the cookie, the token to last. And then essentially accidental exposure of access tokens have no lasting effects because the token refreshes ever so often. So users request new access tokens after existing ones expire. So basically how this works, like very quickly, we'll see this soon in a walkthrough, is that you essentially have two tokens, and then you have like your main token and you have your refresh token. When the main token expires, you then use your refresh token to make two new tokens. So basically it's like a one-time use to replace previous access tokens. So we'll walk through that. Now. So basically we have, again, our registration, making a new user. We have our username and password. create new user, create new tokens. So note how it says tokens, plural. So the 2 tokens will be your main token and then your refresh token. And then you're going to return these 2 tokens. And then that goes back from the server to the client. Then the next time you want to access resource, you're making a request, you're gonna send your access token from the client to the server. Then the server is going to validate that token and then do whatever it needs to do, and then give your return response. And then say you have an invalid token, you're going to then give a return response of, hey, this token has expired. Then you're going to use your refresh token is going to be sent back from the client to the server. And then you're going to validate this new refresh token. And then you're going to create 2 new tokens. You're going to create a new main token and then a new refresh token. And then again, you're going to return your 2 tokens back from the server to the client. So the main difference between HTTP sessions and HTTP tokens is that sessions, you're dealing with sessions and cookies. And if your cookie expires, you need to relog in. But with HTTP tokens, if your token expires, you simply just send, if your main token expires, you simply send your refresh token, you validate your refresh token, and then you're generated 2 new tokens, a new main token and a new refresh token. So again, just quickly going to the benefits. So user credentials are sent less frequently because of refresh tokens. So essentially with this, you can like log in once, and then every time it's like your token expires, your refresh token allows you to refresh it kind of automatically because it gives you 2 new tokens on its own. And then again, you can tune expiration times between user convenience and security. So again, linking back to like the bank versus like your Canvas page example. And then it's more scalable than session cookies. So it's just like, it can be more like widespread to like bigger applications essentially. So then again, here are the 3 mains: basic, session, and tokens. And then we'll be going into demo. Before we start, does anybody have any questions about any of the schemas we just covered? Everybody's good? Oh, yes.
Can I just, like, if I stole a cookie, let's say that you send me information that you have. Like, if I were people undecided and took the cookie from wherever they want to be, isn't that sufficient to just get whatever information you want? I don't have to supply the user information.
Yes. Yeah, I guess. Yeah.
Okay, so the main benefit of HTTP session and token is that there's no permanence in either of these objects, right? You refresh your cookie and you refresh your tokens, right? So if you have basic, then all you're sending in is your username and password, and that's likely going to stay the same per user for a long amount of time. But if you have session and token and you set an expiration time on each of these things, even if you get compromised, you can only use it for like however long it takes until it expires again, right? Okay.
Okay, awesome.